Hi, we have this interesting integral on the board. We have the integral of secant to the fifth x times sine x dx. In the previous video, I did the same integral as this, but I mentioned we didn't want to work with a secant and a sine, so we converted the secant to cosine, and then we were able to integrate the expression with just sine and cosine because those two work together better. But the other alternative is we could turn this into an expression of just secant and tangent, but secant and tangent work well together. So let's do that, and this will be an alternative method, so maybe better. So in order to get this into an expression of just secant and tangent, I'm going to break this up. It's going to look a little funny at first. So we're going to write secant to the fifth as secant cubed x times secant x times secant x, but this last one, I'm going to actually write this secant as 1 over cos x times sine x dx. And the reason I did that, you can probably see, is this whole thing together is actually just tangent, because this is just sine over cosine. So we have a tan x here. And the reason I did that is because this will set us up for a u substitution. Let's just say that u is secant of x. And then if we take the derivative of this, du is going to be secant x tan x dx. It's just the derivative of secant x. But that's actually what we have right here. So you'll notice that we actually have our du here, and we have u cubed right here, is our u secant x. So let's rewrite this thing as the integral of u cubed du. Then we just can use the power rule on this. So the integral of u cubed is going to be u fourth over 4 plus c. Then we just take our u and we'll back substitute. And we end up with secant to the fourth x over 4 plus c. And that's it.